So if you guys remember, SOHCAHTOA means that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Remember, that's what SOHCAHTOA means. It's not a word, it's not another language, it's just something that people like to remember. So you look at the angle that you're talking about, and then this side is right across from the angle that we're talking about, so we call this the opposite side. This one is the very longest side, or you can see that the right angle is pointing to it, and so that makes this one the hypotenuse. And so since this has the opposite and hypotenuse, we would be using sine. So we would say sine of the angle that they gave us, sine of 70, equals opposite over hypotenuse, equals x over 3. And then if we wanted to solve for x, we would just take the 3, we would multiply it to the other side. So the exact answer for x would be 3 times sine 70. And then in our calculator, we would make sure first that if we hit the mode button, it's not highlighted on radians. If I were to type this in my calculator right now, I would get the wrong answer because I'm currently in radians. This problem has to do with triangles, which means this problem is going to be in degrees. So I would need to go down over here, get it so it's blinking on degrees, and press enter. And then I can quit. See the blue up there? I can quit out of this. And then I can type 3 sine 70. It's probably good for everybody to type that. Make sure you get this exact answer. If you don't get that answer, that means you're in radians, not degrees. So that missing side length is 2 point, they said round to the nearest tenth, so that's only 1 decimal place. So 2.8. For this one, they're talking about this angle. So if you look, they did not give us the opposite side. The opposite side has no label on it, so I'm not going to label it this time. This time, they gave us the side that's right next to it. Right next to it is adjacent. That's what adjacent means. The right angle points to the hypotenuse. And which trig function uses adjacent and hypotenuse? Cosine. So we're going to say cos of 41.3 degrees equals adjacent over hypotenuse. And then to solve for x, we would take the 13.4, we would multiply it over to the other side. When you get down here, these ones aren't asking you to find a side length, they're asking you to find an angle. So with this one, we're going to start with the angle just like we did the other ones, because the very first thing we have to figure out is which trig ratio to use. So here's the angle they're asking us to look at. The 9 is across from the angle, so that means it's the opposite side. The right angle points to the 10, that means this is the hypotenuse. So again, this problem is talking about sine. So sine of theta is opposite over hypotenuse. And if we're solving for the angle, that means we need to undo the sine. Does anyone remember how to undo sine? Sine inverse, okay. Now for this, this is not like when we were doing the unit circle and we have to get 2 answers. We are just going to get the 1 answer, and the 1 answer it's going to give us is correct. Because if you guys remember when we were doing the unit circle problems, the first answer that we got when we did sine inverse was on the top half of the unit circle. The top half of the unit circle is between 0 and 180, and a triangle is between 0 and 180. Does that make sense? The second answer on the unit circle was between 180 and 360. Triangles are not between 180 and 360. So when we do sine inverse, we are automatically going to get the correct answer. We're not going to get the second answer on a unit circle. Does that make sense? So we're in degrees. We're going to do sine inverse of 9/10, and we do not have to worry about a second answer like we did last unit. We just get to do 1 answer, and we are good to go. 64.2 degrees, because they're asking us to round to the nearest tenth, which is 1 decimal place. So 64.2 degrees. Okay, is that a good reminder of how to do these? Yep. Okay, so go ahead, work on finishing the warm-up. This is the skill that we're going to be using today. So make sure that if you have questions, you kind of get them figured out now, because later today we're going to be doing application problems, which means we're using this skill, but we're doing it on word problems. We're not just going to be doing straight math problems, we're going to be using word problems today. Right triangle trig application. So at the top we're going to write SOHCAHTOA so we don't forget that. SOHCAHTOA. So these problems are going to be pretty simple. They're very similar to the warm-up. The one difference is you have to write your answer in the context of the problem instead of just saying x equals something. So the most important thing I've noticed when I do these is you should draw a picture to represent the situation. Don't think you can just do it in your head. If you draw a picture, you get to use your common sense to help you figure out the problem, just to make sure you're labeling the different sides of the triangle correctly. When you draw the picture, try to make it lifelike. So if it says there's a boat, draw a boat. If it says there's a tree, draw a tree. The picture doesn't have to look good. It just has to be accurate enough to help you use your common sense so that you're not just drawing a triangle and then accidentally drawing the triangle incorrectly. Okay? So when I see these pictures, I shouldn't, for any of these problems, just see a triangle. If it says draw a ladder, draw a little thing that looks like a ladder. If there's a person, draw a stick figure. It's not an art class, but your picture should be realistic enough that your picture is not completely wrong because you were being lazy and just drawing a triangle. Okay? Then from there you can determine which trig ratio to use because you're going to label 2 of the sides, and then you're going to solve the equation, and then at the end we're always going to write our answer in context, which means we're going to use a sentence. Okay, so this first problem says a 5-meter long ladder leans against a wall with the top of the ladder resting 4 meters above the ground. So I'm going to draw like the side of a house, and here's some grass. Some good looking grass, and then here's my little ladder. It's leaning against the wall with the top of the ladder resting 4 meters above the ground. So this side is 4 meters. Now, this other part you can do with a color if you want, or you can leave this as just pencil. It's up to you. Sometimes using a color can make it make the triangle stick out a little bit more. So if you want to really see the triangle, then here is our triangle. Here's our right angle. So we've got the 4 over there. The ladder itself is 5 meters long, so this side over here is 5. What angle does the ladder make with the ground? The ladder, the ground, so this is the angle that they're talking about. So I draw the picture, I make it somewhat lifelike so I can use my common sense in helping me label the picture. Now sometimes you don't have to do that because sometimes they'll put a picture with the problem, which is always my favorite, but every so often you have to draw it yourself. And then from here we're going to figure out which trig ratio it is by labeling the picture. So there's my angle, There's the opposite side. My right angle points to the 5, so this is the hypotenuse. And so which trig function am I using? Sine. Opposite and hypotenuse is sine. There's a typo, that's fine. So sine theta is opposite over hypotenuse. And then what am I going to do to solve for theta? Do the opposite of sine, so I'm going to do sine inverse on each side. So sine inverse of 4/5 is what I'm going to type into my calculator. So sine inverse of 4/5. 53. The problem didn't say what to round to, so I'm going to do 3 decimals just because I know that's what I typically do. 53.130, and then I'm going to write the answer in a sentence. So the ladder is making a 53.130 degree angle with the ground. All right, brain's feeling good? Making sense? Okay. Now, there are 2 phrases that you might see in a problem that, to me, don't make automatic sense. So some of these, when you draw the picture, it will feel like it makes sense. You'll read it and you'll be like, yep, I can tell exactly how I should draw that picture. But then sometimes when you read it in the problem, you'll be like, I have no idea how that should be drawn in the picture. So angle of elevation and angle of depression are the 2 phrases that are common for these problems, where when you draw it in the picture, you might not know how to draw it. So angle of elevation means that if we have somebody in the picture and it says their angle of elevation, that means that they are looking straight out and they are looking up. So this is where your angle is. They are looking straight out and they are looking up. Angle of elevation. So whenever you have an angle of elevation in the picture, you're going to look for something to be straight out and up. Angle of depression is going to be somebody who is looking straight out and down. Straight out and down. So angle of elevation seems to be the one that's a little bit easier. That one feels a little bit more common sense. Angle of depression is the one that usually messes people up. And if you're not paying attention, you might draw the triangle incorrectly. Okay? All right, so next we have a tower that casts a shadow that is 60 feet long when the angle of elevation of the sun is 65 degrees. How tall is the tower? So I'm going to draw a tower. I'm not good at drawing towers. Is that a tower? I don't know. And here's the sun. Don't laugh at my drawing. I heard the snicker. And then it looks like a crayon. I drew a crayon.
Oh, crayon. I didn't know what you said. I was like,
Crayon?
Crayon.
Okay. And then here's the shadow. So the sun shines into the tower, right? And it creates a shadow. You guys all see that, right? Yeah. Okay. So now what I'm going to do is I'm going to draw my triangle. Here's my triangle. The shadow is 60 feet. They're asking how tall is the tower. Here's my 90-degree angle. Where is the angle of elevation of the sun? It's the bottom. Because it's got to be straight out and up. Does that make sense? It has to be straight out and up. It would be very tempting to think that the angle of anything that had to do with the sun is this one, right? That would be very tempting. But angle of elevation means straight out and up. Does that make sense? Yeah. Okay. So the 65-degree angle has to be this one, because that's what angle of elevation means. Straight out and up. Okay, so here here's the angle we're talking about. This side is the opposite. This side is the adjacent. So we are using tangent. Finally, we get a tangent problem. Okay, tangent of 65 equals opposite over adjacent. Okay. And then what should we do to solve it? Multiply by 60, multiply by 60. So x equals 60 times tangent of 65. 60 times tangent of 65. 128.670. 128.670. Okay. And now I'm going to write the answer in context. The tower is about 128.670 feet tall. All right. Matt. Matt is a person standing on the top of a cliff. So here's my cliff. Here's Matt. The cliff is 305 feet above a lake. Okay? This is 305. The measurement of the angle of depression to a boat on the lake is 42 degrees. So here is my boat. I'm really good at drawing, in case you can't tell. My college math professor said that all future math teachers should take an art class because you need it for when you draw pictures for math problems. And I was like, I'm not going to be an artist. And now I understand why. Okay, so the measurement of the angle of depression to the boat. And they want to know how far is the boat from the base of the cliff. So here is our triangle. Here's our 90-degree angle. We know that the cliff is 305 feet above the lake. We know that we're looking for this. Okay? Now, angle of depression. Tell me how angle of depression works. Straight out and down. Did I draw anything straight out and down? I did not. So I'm going to draw an alternate triangle. You're going to see it. Straight out, right? Because angle of depression is straight out and down. Straight out and down. Do you see it? Yeah. This is the angle of depression. This is 42. Everyone see that? That's 42. So this length right here is also x. This length over here is also 305. Everyone see that? So angle of depression, straight out and down. Okay, now this 42, we can solve this top triangle, but this 42 is which angle in the orange triangle? Is it the left angle or the right angle? The right angle. It's the right angle. 42 over here is the same as this one over here. See how important it is to understand what angle of elevation and angle of depression mean? It would be very easy to find the wrong angle. Okay, so the hard part of the problem is not knowing SOHCAHTOA. SOHCAHTOA is the easy part of the problem. SOHCAHTOA is part of Math 2 curriculum. You guys learned that a while ago in theory. The hard part of the problem for these really is understanding the wording of the problem and what it's asking for. Does that make sense? That's the reason why we're going over it in Math 4. Okay, so we've got angle of depression. We know that this is the length that we're finding. We know that it's 300 feet above. So now I can go ahead and do my labels. So here's my angle. I've got the opposite. That one is the hypotenuse. That means this one is the adjacent. So which trig function am I using? Tan. So tan of the angle is opposite over adjacent. And this is one of the ones that's a little bit more tricky because the variable's on the bottom. So what do? Multiply by x. Okay. X times tan 42 equals 305. And then how do I solve for x? Divide by tan 42. X equals 305 over tan 42. Okay, so 305 over tan 42. You can type it in just like that, 305 divided by tan 42. Your calculator can handle that just fine. Or you can type it in as a fraction, and you can do alpha y equals, and get the fraction, number 1, get that on your screen. And then you can type 305 on the top and tan 42 on the bottom if you want it to look exactly like what's on your paper. So both of those will give you the same answer. So 338.737. The boat is about 338.737 feet from the base of the cliff. Now, when I did these examples with you, I chose examples where you could see a good a good situation where angle of elevation and angle of depression were a little bit less straightforward. There are some problems where the angle of elevation is exactly what you would think. You draw the triangle and you say straight out and up, this is what I think it would be, and they go, yep, straight out and up, that's exactly what it is. It makes a lot of sense. But then there's some where it's kind of funky like this, where you're like, wow, if I had not known what that phrase means, I never would have known what to draw. Okay? So some of them are straightforward, but now you have two examples of how funky it can be. Does that make sense? So some of them are truly going to be like this, where they give you the situation, you draw it, and you go right into the problem, and you have no issues, okay? But some of them, you are going to have to be careful and think about it when you do it, okay? All right, so I'm going to go ahead and hand these out. We have 11 problems to do. That's the plan.